Alright, here we go. So the first part of your note says describe or draw an anticyclone or high pressure system. So first we have to know is that it starts with high pressure. So that's caused by cold air sinking. So the cold air there sinks down. After the cold air sinks, it starts to warm up. Well, we have to think about what that does to the capacity. So let's chase that variable. So the capacity up high is low, but as it gets warmer, the capacity increases. Well, then we have to chase that variable. What's that going to change? That's going to change relative humidity. So the relative humidity is going to be lower down at the bottom, which makes it sunny. We also know that wind blows from high to low, so it's diverging at the surface, and then the opposite happens at the top. It is converging at the top. So that is kind of your little description of a high pressure system there. And on a windy day, this might be something that you'd look at. One of the terms you'll see is a steep pressure gradient or a gradual pressure gradient on your exam. And so here we see over the South Dakota and Nebraska area, those isobars are really close together, and you can see whoosh, get some really fast wind speeds kind of spiraling over there. And today we're going to talk about jet streams, and we're also going to talk about severe weather. We already know from wind that it's caused by differences in air pressure, and that's slowed by friction, things like buildings and trees and whatnot near the surface. And once you get up higher, above that tree line, above the building line, that friction really becomes like nothing above that layer, and so that allows for really high wind speeds. And hopefully what you saw when you were doing your pie plates was the faster you took that pencil across the page, the greater the Coriolis effect. You got a steeper, more rounded line. And so with that greater Coriolis effect up there at above that friction layer, you get winds that blow parallel to isobars, and those are jet streams. And so jet streams are really just fast-moving rivers of air, and they're responsible. What's important about them, though, is they push these air systems, these high-pressure systems and low-pressure systems around on the surface of the Earth. But they also give us that convergence or divergence that happens up high at the tropopause. And so that's what maintains those cyclones and anticyclones as they move across the country. And now for some more fun stuff. Severe weather, thunderstorms and tornadoes. You already know what a thunderstorm is. It is a rainstorm that has woohoo, lightning and thunder. And they form when really warm, humid air rises in an unstable environment. And there's 3 stages to a thunderstorm. The first one is the beginning stage. And so just keep in mind, when air rises, it cools, and when it cools, its capacity decreases. And then if it becomes saturated, you can form a cloud. And so that's kind of the basic process. But the first stage for that process is called the beginning stage, and that's when that unstable air rises in quickly. And unstable air is sort of like a lunchroom. So you can imagine a stable lunchroom is one where everybody sits in the same place with their same group of friends every day. And that would be unstable if you go to your regular table, but your friends decide, I'm going to sit someplace new today, and they sit someplace else. You'd probably take up your tray and go sit with them. You'd move because you were unstable. And so unstable air masses go and move towards air that is more like them. But air will move up or down to get to be stable. So when you have this warm, moist air that's close to the ground, it wants to rise, and so it rises quickly, and then it cools quickly, and it makes a cloud. And so as that happens, then water is going to condense, and latent heat is released. Well, that latent heat actually makes it so that it keeps the air warm, and it keeps the air rising longer than it would on its own. And that makes the cloud become taller. And that stage lasts about an hour, but that's not necessary for you to know. After that, it's called the mature stage. And so here you get the water droplets that are just too heavy for the cloud, the updraft, to keep up. And so it starts to rain. And as it rains, that water starts to evaporate and cool the air, and so you start to form a downdraft. So now you have an updraft, that's the hot air rising, as well as a downdraft, the cold air sinking. So in that mature stage, that's the primary characteristic, is you have both the updraft and the downdraft. And it can get more complicated than that if stuff starts to tilt a little bit. With stronger updrafts, what you end up with are solid particles of water, which is hail. You can kind of see that here. You've got an updraft here where this bump is, and then you've got a downdraft here, and so you can imagine that water would lift and it would freeze up here where it was cold. It starts to fall, and then it might get caught back again and go around and around, and the more times around it goes, the bigger the hailstone gets. So here on the left we see the world record holder of ice this hailstone. And this is a person's hand, so you can see the thumb here and the fingers kind of over here. So it would fit in the palm of your hand. But what's interesting to notice are these concentric circles. And so that represents trips up and down through the cloud. So each time it got more and more water put on there until it wasn't that big. This is the current record holder here on the right. You can see that 3-inch mark here and a 10-inch mark here. That's about 7 inches all the way across. It's about as big as your head. Okay, is this hailstone. That's the current record holder. It was collected in Aurora, Nebraska. So that is the most current record holder. It's about the size of your head or about the size of a small soccer ball. Finally, though, what happens is that evaporation, that cooling process, cools inside that thunderhead, and it causes those downdrafts to eventually dominate over those updrafts, and the storm cell dies out. Those downdrafts cut off the fuel supply of that warm, moist air lifting, and the actual cloud, as it evaporates from the bottom up, and so it will shrink. So here it would start to lift and lift and lift, and this bottom part would lift upwards. That's one thing that I don't like about the image that's in your notes. Your image has got a great beginning stage, a great mature stage, but this dissipating stage here, this is what I like about this one, is that you can see it lifting. What you need to know for a test is where you have updrafts and where you have downdrafts. So this beginning stage you have updrafts only. The mature stage you have both updrafts and downdrafts. And then the dissipating stage you have only downdrafts. A severe thunderstorm is just like a thunderstorm, but the whole thing about a severe thunderstorm is it has to have 2 inches of hail, 2-inch size hail or bigger, which would be about the size of your index finger. And wind speeds are going to be high enough to be like 50 miles per hour, which would be approximately the amount of wind it would take to rip off shingles off of your roof or take down fairly large branches. And that happens where you have strong vertical wind shear. So in other words, the updraft and downdraft are both very, very strong. And some of those can lead to tornadoes. In your I'm going to connect a YouTube of Vortex 2. I'm not going to go through it right now, but it's kind of a fun one to watch. It shows the whole evolution and dissipation of a tornado.
We've got.
So I'm going to skip through that there, but that'll also be on your YouTube link. So just for tornado formation, know that we don't know everything. It takes 2 things: a mesocyclone and an updraft. And so a mesocyclone is when upper winds are blowing at faster speeds than surface winds, and it causes those winds to kind of roll across the surface. So here we kind of see this upper wind is going much faster than this bottom wind, and so you see this kind of rolling along the surface of the earth. Well, then along comes a thunderstorm, and it has that updraft, that hot air rising, and that updraft kind of bumps into that rolling wind and stands it upright. And so this is that radar signature that they're going to be looking for, is when the red is right next to the green. Now, when you're looking at a radar signature, normally you'll see half of the screen would be red and half of the screen would be green. So what they're looking for is the red right next to the green inside of some portion of that storm. So you'd have a little blob of red inside the green or a little blob of green inside the red, and that's where they would know that this mesocyclone is going on. Now, this isn't the tornado itself. The tornado itself is then so this would be the updraft, and then what happens is in the downdraft that we have some conservation of momentum that happens, and so as that downdraft comes down, it tightens down as it reaches towards the surface of the earth, and so we would get the tornado behind that mesocyclone in the thunderstorm. What would this look like if you were at home? Let's say you lived like right here where this word horizon was. As the storm moved into your area, first you would feel a bunch of wind, and the temperature would drop significantly. This would be this cold front that would happen here. Next, what would reach you is this area of rain, just a thunderstorm. So you'd see some rain kind of coming in. Eventually that rain would intensify, and then you'd get to some hail. And so that hail would then happen. And depending on the size, that doesn't really matter in terms of tornado formation. But what you would look for next is you would look for an empty spot. So what would happen is you'd go wind, rain, hail, and what happens next kind of tells you if you need to go to the basement or not. So if it goes wind, rain, hail, and nothing, you need to get to the basement because you have now hit the updraft, and what's coming next is a tornado. If it goes wind, rain, hail, and then it starts raining immediately again, you probably don't have anything to worry about. The storm wasn't strong enough to make a tornado. So it goes wind, rain, hail. If there's nothing, that means you're right here, and that tornado is coming down here behind you. Eventually, it will turn back to hail and rain again before the rain tapers off. And what we're looking for, though, is that wind, rain, hail. And if it rains again, you're okay. If it doesn't rain, goes wind, rain, hail, nothing, you need to get your butt to the basement. So here is what's called a rain-free zone. Mr. Bueland took this picture off of his balcony one night when we had some tornadoes here in the Omaha area. And what you can see is this tree is just kind of hanging out. No wind, nothing really happening. You can tell from the street that it has rained recently, but there's no rain coming down right there. Then he turned on his deck, so got a different angle, so he turned and looked the other way up the street. And here's what we have. We have this funnel right here coming down nice and square-like. And then right here you can see I bracketed it with some blue lines to help you see it. But there is a wall cloud, and a wall cloud is, again, it looks like a square cloud, but it's spinning. And so that wall cloud indicates that a tornado warning should be issued. And then the funnel starting to come down as well. And that also would give us that's enough to give us a tornado warning. Eventually, though, this tornado did not make it all the way to the ground, thank goodness. And you can see that wall cloud here is really starting to fall apart. So this did not hold together very well. It was not a tornado that caused damage because it never actually touched the ground. And Omaha got pretty lucky because what you're seeing underneath there is all these apartment buildings. And obviously, Mr. Bueland was not in a very smart spot when he took those pictures. All right, so that's severe weather. Please know the beginning, the mature, and the dissipating stages of a severe thunderstorm for your exam this week. All right, talk to you later, guys.